All right, welcome ladies and gentlemen to our second lesson in the study of polynomials for Algebra 2. This is going to be looking at the zeros of a polynomial, something called multiplicity, and looking at what a linear factor is going to do for us in the study of polynomials. So let's go ahead and get started. So first of all, let's look at a zero of a polynomial, and we dealt with this a little bit in quadratics. The zero of a quadratic is what x value or x values that make a polynomial function equal to 0. Now, graphically, something we're going to do later in this study of polynomials, graphically, it's where the graph crosses the x-axis. Now, we didn't really do that in quadratics, but we're going to really stress it here in the study of polynomials. But let's get away from the graphic piece. We're going to look at the x values that make a polynomial function equal to 0. So if I was to give you a polynomial function like this cubic, right now we have no method of creating the zeros as of right now. We have no way of knowing what the zeros are without guess and check. So this is kind of hard to do by hand right now. We'll figure out ways to do this later in this unit. But what if this problem was factored for us? So I have this problem here that's the same equation. So f of x is equal to x plus 2 times x minus 3 times x plus 3. When you FOIL these together, you actually get this original thing. So might be a precursor to what's going on later in the unit. We're going to be figuring out how to factor this cubic. But right now, we're going to be looking at factored forms. So if we were to look at the factors here, and if we said this f of x is equal to 0, so if we said equals to 0, we could figure out that if x is 3, and we plugged in 3, we would get a 0. And if we plugged in certain things, we get 0. So here, the values that make f of x equal to 0 are -2, 3, and -3. And that comes from plugging in a -2 in this factor. If I plugged in a -2 here, this would be 0 times all of this junk, which makes 0. If I plugged in a 3 into the middle factor, that would make a 0 there. And if I plugged in -3, it would make a 0 on the right-hand factor. So these are the 3 zeros of the polynomial f of x. Now, this is a very quick thing. We are going to use these, obviously, later in the study of polynomials, as I mentioned the thing about graphing. So we're going to use those later, but let's look at a couple of examples. We have g of x, which is 2x plus 1 times x minus 2 times 3x plus 4 times 6 minus x. Now, if we were to figure out the zeros for this polynomial, we would just want to know what x values make this thing 0. And it's actually not that bad. If I wanted to know what makes this 0, I would just write it. I would say, okay, well, what makes that 0? 2x plus 1 equals to 0. And if I subtracted 1 and divided by 2, I would get x is equal to -1/2. Here, x minus 2, well, if I plug in a 2, that makes a 0. In the next one, if we were to think about the same way we did the first one, we would subtract 4 and divide by 3. So it's a subtraction of 4 and dividing by 3. And then 6 minus x if we plugged in a 6. And note we get our 4 zeros of our polynomial g of x. So on this last example here, pause it and see if you get the same answers that I do here in a moment. So I'll let you pause. And when you come back, I'll solve the problem. All right, so we get x equals, let's start with the middle one here, x minus 1, so that would be a 1. Here I would add 5 and divide by 2, so if I added 5 and divided by 2, And then the last one is the one that a lot of people miss. You need to make sure that this piece here is also one of your zeros. And if I plugged in x equals 0, I get that last 0 of the polynomial. All right, so that's zeros, just figuring them out from factored form. Let's take a look at the next piece. So the next piece for us is a repeated 0. Now this plays very heavily into how to how to graph polynomials, which we'll get to, like I keep mentioning, later on in our unit. And the repeated 0 is just a 0 that occurs more than once, hence the word repeated. And we say it has a multiplicity. And multiplicity is just a fancy way of saying the number of times it's repeated. So if I gave you the function m of x is equal to x minus 2 squared and x plus 4 to the third, this really does come down to this. If we were to write it all the way out, we'd say x minus 2 squared means multiplied by itself, and then cubed means multiplied by itself 3 times. There we go. And the zeros here are x equals 2, which makes the first one 0, with a multiplicity of 2 because it occurs 2 times. Notice that kind of right there. So we get a 0 of 2 with a multiplicity of 2, and we get a 0 of negative 4 with a multiplicity of 3. Now note, this part here is not necessary. All I get these answers from is the 0 of the thing in the parentheses, and the exponent is the number of times it's repeated. So if we look at this problem here, h of x is going to be already in factored form for us, obviously. And we look at this and we say, well, when we had an x in the front on the last problem, that meant that x was 0. But in this case, it happens 3 times. So we say multiplicity of 3. We can say x equals a 1 with a multiplicity of 2. And we can say that x is equal to the last one, which only occurs once, so we don't have to write multiplicity. But if I add 7 and divide by 2, I get 7 over 2. And there we have it. That's finding the zeros, now including what we call a multiplicity or repeated 0. All right, if we'd like to go from the polynomial in factored form into its zeros, we need to know how to go in the other direction as well. So this one's going, given the zeros, we're going to write the function in factored form, and then we're going to put it in standard form. So if I gave you the zeros of x equals 3, 4, and 2, if 3 is one of my zeros, that means x minus 3 is one of my factors. So we can write our function in factored form. Thusly, we can say x minus 3, which gets me a 0 of 3. We can say x minus 4, which is a 0 of 4, and x minus 2 from the 0 of 2. And then, as we did in the previous lesson, we can say, oh, let's multiply these together. So if I multiply the first two, x minus 3 and x minus 4, I get x squared minus 7x plus 12. And then I'm going to distribute the x and the minus 2, and I get x cubed minus 9x squared minus 2x minus 24. So that basically goes right along with what we did in lesson 1 for polynomials, starting with factored form and writing it down in simplified standard form by using the FOIL method. So if we were to write the next one here, in factored form. There we go. We write the next one in factored form here. We would say the 1/2, that's the tricky one. So let's deal with first the 0. If x is 0, that means I get x by itself. And it's a multiplicity of 2, so it's squared. The -1 would be x plus 1. The 1/2, now most people are going to write this, x minus 1/2. But then we have to deal with multiplying by fractions. So what we normally do here is we write this by maybe looking at it like this, but if we multiplied by 2, we'd get 2x and a -1. So that is the factor that I want to deal with. And then by looking at this, then we can FOIL. And I want to FOIL the first two pieces first. So x times 2x gets 2x squared. I get a plus 2x and a minus x, which gets me a plus 1x. And then 1 times -1 is a -1. And then I can distribute the x squared. And I get 2x to the 4th, which is x squared times 2x squared. X squared times x, which is a plus x cubed. And x squared times -1, which is a minus x squared. And there we have standard form for a polynomial given the zeros. All right, last new piece for us in this particular lesson is factoring. I know I mentioned earlier that we don't have a way of factoring, but we have a way of factoring simpler versions of these polynomials. So we're going to start off with GCF factoring. Remember, that's greatest common factor. We're going to be taking the GCF out, and then we're going to factor the simple quadratic that is left over. For example, if we were given x to the 4th plus 6x cubed plus 8x squared, and I looked at that polynomial, I know that all three terms have an x squared inside. So what I'm going to do is I'm going to factor out x squared. So I took out the x squared. This second piece becomes x squared plus 6x plus 8. And this quadratic inside the parentheses is now factorable. The two numbers are going to be 4 and 2 because 4 times 2 is 8 and 4 plus 2 is 6. So this goes right back to our quadratic unit and how to factor a quadratic. And we get x squared times x plus 4 times x plus 2, which gets us the zeros of 0 multiplicity 2 from the first one, -2 from the last one, and a -4 from the middle one. So it comes down to being able to factor out a GCF and then coming down to factoring a quadratic. So here is our example. Once again, you can pause it and do it to see if you get the correct answer. All of them have x. So I get x squared minus 4x plus 4. And I get x times x minus 2 times x minus 2. And normally we would write that as x times x minus 2 squared, because I have 2 of those x minus 2. So we would say our zeros are x equals 0 and x equals 2 multiplicity of 2. And that is going to complete this lesson. We are going to move on into the next lesson. You'll notice down here at the bottom, our next lesson is going to be talking about end behavior and how to sketch a graph from factored form. I'll leave you with this comic, and I will see you guys tomorrow.